Good day, good day, good day, and welcome to Africa Teen Geek Online School. Yes, my name is Nonkululeko Madondo, and if you have just joined us in, you are here for Physical Sciences Grade 11. I hope that everybody is having a good day and you've been working hard on your chemistry, like we've been doing for the past 3 weeks. We started with chemistry, chemical changes, part one, and from today we're starting a new chapter, which is chapter 7 on your Oxford Successful textbook. I hope that most of you are getting a hold of this Oxford Successful textbook. You can get it on Snaplified. Snaplified is an app that you can get on your Play Store, or you can even get it on your PC, and you can download all your textbook, not just physical sciences or Oxford, but any textbook. They're absolutely free until the end of the year. This is, a thing that's done because of the COVID-19 problems. So they decided to make all textbooks free until the end of the year. So you can take advantage and get yourself some books. Once again, you can get me on social media. It's LinkedIn. My name there is Trio Madondo, and you can send me a DM with whatever problem that you guys might have. Just let me know, and I'll definitely, uh, you know, respond, and we can work some of the problems. Or even if you have some exam papers and you've got problems where you're stuck with regards to, because I want us to stick to the topic at hand. So if with stuff on energy changes or reactions or whatever we're doing in this chapter, then you can just send it to me, and we can discuss it, and I can try and explain it to you guys. Okay, if you've just joined in, this is your physical sciences grade 11. We've done our revision for chapter 5, and I hope that that gave everybody an enlightenment of what is going on. Maybe if we still have some time, we can go and just finish up the number 10 that we didn't finalize yesterday because of time. But I'd like us to, do start with our chemical changes in reactions, which is the first unit on our Oxford Successful textbook with chemical changes part 2. So if you guys remember properly, we started with chemical changes part 1. That had to do a lot with the quantitative, how much each reaction is, how much substance, how much elements gets put in each equation. So that's what that was about. So now in chemical changes part 2, we're dealing more with the reactions, the type of reactions, what it entails, and for like basically what kind of energies are used to break bonds, etc. So that's what gets done here on the second part of chemical change. I'm just trying to slide just to show you guys an outlook of what we're going to be working with. Okay, I am muted, but okay, no, it's fine now. I was almost muted, and I'm sure you guys couldn't hear what I had to say, but I'm just trying to get to the next slide. Okay, here we are. So this is the outlook of our chemical change part 2. Um, what we're going to be working with. We're going to have two parts of it. We're going to have the energy and chemical changes, which is what we're going to start with today. And then thereafter, we're going to go straight to the types of reactions. So on the energy and chemical change, we're going to work with the bond energy changes, exothermic and endothermic, and activation energy. Okay, so we're going to be doing one unit each and every day just to make sure that everybody is catching up and everybody understand what we're doing in every section. But also bear in mind, guys, do not forget everything that we've done in chapter 5, because it's all chemistry. You might find that in the future there will be some reaction that remind you of the stuff that you did in chapter 5. And then after that, we're going to work with the type of reactions, defining acids and bases. And basically in this part, we're going to start understanding how each elements are combined together and how they form bonds together. The define acids and bases, indicators, and also the reaction itself, that how does it actually come about. Okay, so I hope that you guys are excited and will be participating here on fourth. Okay, so now we're going to go straight to the first part of our chemical changes part 2. And okay, so in unit 1, we're going to be talking about energy changes in reactions. So these are the following things that we're going to be discussing today. We're going to be, okay, these are the following things that we're going to be discussing today on unit 1, energy changes in reactions. We're going to first have chemical changes and heat. We're going to talk about that. And then we're going to talk about endothermic and exothermic reactions, what it means. So here, basically, it's a defining point of each and every part of what we're going to be working with in this chapter. And then we're going to do bond breaking and bond formation, okay? So I hope that you guys are having your Oxford Successful textbook. But today, I'm going to be inter alia working with the Oxford Successful textbook, but I'm also going to be referring a lot to the Siyavula textbook. So those are my references for the lesson that we're going to have today. So if you do have your Oxford Successful textbook, you'll be able to follow through on the lesson that I'm doing today. Why are we using one textbook? We're using one textbook because in other textbooks, the units are mixed up and the chapters are in different places. So we use the Oxford Successful textbook in order for us to have a trail on how to follow through from each unit to the next. So please, guys, if you can get it, download your Snaplify and get yourself a Oxford Successful textbook and let us work. Another thing I wanted to remind you guys is that you can send me a chat, whatever I'm explaining. If you get stuck somewhere, just send me a chat and I'll be able to explain something that you are having a problem with. Okay, so we're going to start on energy changes in chemical reactions. Okay, what do we know about energy changes in chemical reaction? We know that all chemical reactions contain energy changes. Okay, that's the first thing you need to know. Every chemical change, there's some change in energy. So what does that mean? That means that it's either we're going to use energy or we're going to release energy. I hope you guys understand. For example, here I've got a picture of this fire. This is an example of energy that was released in a chemical reaction. Okay, in reaction, energy is either released or it is absorbed. Okay, reactions involve releasing heat or using heat for the reaction to take place. For example, maybe we'll take, for example, element X and we add heat, or for example, you have to light it up with the matches for it to give out a product. That will be us, using heat for the reaction. Or sometimes, whatever reaction that you make results in, for example, a firework or explosion like this, and that would be a reaction that releases energy. I hope that you guys understand. Okay, so what we also know is that thermodynamics is a study of heat or flow, energy flow in chemical reaction. So this is what we're going to be working with a lot in this chapter, thermodynamics, heat flow, heat changes, the difference in heat, and that's all that we're going to be doing in this chapter, because that's what it takes to have a fully complete chemical reaction. Okay, and then yeah, we're moving to the next one. It says chemical changes and heat. Okay, chemical changes and heat. So what we need to know is that during a chemical reaction, atoms of reactants rearrange to form solution and product. What does that mean? It means, for example, you're going to have H2 plus O will give you H2O. Okay, so what it means here when they talk about atoms react to rearrange to form solution, sometimes you get that you've got um, the reactant A and B, which gives you C and D, but you find that they've been rearranged in each other. Okay, so that's what they mean when they say that they rearrange. So what happens is the bonds need to be broken. When the bonds break, they need to rearrange to form a certain product. So this is what it means when it says atoms of reactants rearrange to form a solution, which is our product in this case. Okay. Some reactions release heat and others absorb heat. I think we've already mentioned this, that sometimes reactions will differ depending on what type of reaction that is. Okay. And then we've got an important thing that we are mentioning here with regard to this chapter, which is enthalpy. Okay. Which is enthalpy, or we call it the heat of reaction. Remember, we spoke about that we either use heat for the reaction or the reaction results in heat. That heat, okay, is the what we call enthalpy, which is in a form of H, okay. The unit is H. Okay, this is the heat content of the system, okay. So what they say here is that enthalpy cannot be measured, but the changes of H can be calculated. So what does that mean? Is that we don't know how much the heat is, but what we can find out is the change. For example, um, the product minus the reactant, the heat in the product minus the heat in the reactant will give you the change in heat, and that's how we get to calculate the change in enthalpy of a reaction. I hope you guys are still understand what I'm saying. And if you don't, just send me a chat and I will explain whatever you guys can expect. Okay. And then nowadays, this can be found by measuring different temperatures of the reactant and the temperature of the product. Okay, which is exactly what I just mentioned. That you take the heat value in your product minus the heat value in your reactant, and that gives you the change in heat. But what is the heat product that we're talking about? In this case, we talk about the temperature. The temperature is what we use to calculate our enthalpy or find out the change in enthalpy. So enthalpy, we can easily say that it is the temperature. So use temperature when we calculate it. Okay, then what is enthalpy changes? Enthalpy changes heat added to a system under conditions of standard pressure. Okay, so for two definitions that we've learned in this part. There's two definitions that we've learned in this part, which is the enthalpy and enthalpy. And this is important that you have to know it, as it's a good baseline for the start of our chapter. Okay, so moving on. Okay, I see. Moving on, and I hope that everybody is following through what we are saying. Okay, ma'am, I can't hear you. I don't know what is wrong. Okay, what about now? Do you guys still have a problem hearing me? Please just send me a hand if you can hear me properly when I speak. Can everybody hear me now? Yes, it's so much better. Okay, I'm glad that it's so much better. Let me just get my screen back. So now we know in order for us to have a reaction, we need enthalpy, and there's always enthalpy involved. And enthalpy in this case could either be the heat Actually, it's not either B, it's always there. It's either the heat that is used to break the bonds, and it's also the heat that is required to form the bonds. So now we have understood what enthalpy is. I hope that everybody got that before they stopped hearing what I was saying. So enthalpy changes is the heat added to a system under a condition of standard pressure. So that heat energy is the difference between the heat used to break the bonds and the heat used to create bonds in the product side of it. Okay. Yes. Let me just see. I think there is a picture. Uh, Let me just try and get a screen share of a picture Okay, just before we get to the endothermic parts. Okay. Okay, the computer is a bit slow, but I just want to show a picture of, yes, of the energy changes. Okay, so but we're not going to be doing the experiments because we obviously don't have a proper laboratory where we can do the experiment. So, okay, I can't find a picture now, but let's continue and I'll send it to you guys as soon as I find one. So we're moving on now. Now we're going to our second part of this unit, which is the endothermic and exothermic reaction. I'm sure at one point in your academic life, you've heard of this too because it's the biggest reaction that it's always spoken about, especially when we do chemistry. So what do we know? We know that thermic means heat. So exo means outside and endo means inside. Okay, so here I've got a little picture of, let me just widen it up for you guys to see. Let me just close our teacher up for 2 seconds. Sorry, teacher's face. I just want to make sure you guys can see it properly. So this is an endothermic reaction and this is an exothermic reaction. So you can see here, in the endothermic it's taking in heat, in the exothermic it's taking out heat. What does this mean? It means the fire picture that we just saw on the previous slide, which is this one. It means it's an exothermic reaction because it's releasing heat and not taking it in. Okay, so they say here that an exothermic reaction is a reaction where the energy used to break bonds is less than the energy of the product. Okay, do you guys understand what that means? It means that very little energy is used to break bonds, but more energy is released in the product part of it. Okay, the reaction where the energy used to break bonds is less than the energy of the product. So basically in this reaction, energy is released whenever release exo. So basically you can just channel your mind that exo means exit, endo means inside, but exo is going to be a good one because exo exit, you know that energy is coming out, because sometimes you might forget to put these two words in the right place. Okay, so in this reaction energy is released, so it means that the reactant gives out the product plus the energy, fire for example. Okay, so then we move to endothermic reaction. Endothermic reaction is a reaction where the energy that is released is less than the energy used to break the bonds of the reactant. Okay, so which means this bond of the the reactants are bonded together, so the energy used to break them is far more than the energy that is um, that is uh, that is released on the product side. So this energy, this reaction is an energy absorber. Okay, so the reactant plus the energy gives you the product. Okay, I hope you guys understand. So here you can see there's a little summary. You can also get it on your Oxford Successful textbook. It says in an endothermic system, the surrounding heat is absorbed, and this surrounding system, the heat is released on exothermic. So in endothermic, the change in enthalpy, so you always know when you see the H, it's enthalpy. And what is enthalpy? Is the energy that is used to break or make bonds. Okay, simple definition. So when the change in H is greater than 0, we know that this is a endothermic reaction. But when the change in H, which is a change in enthalpy, is less than 0, then we know this is an exothermic reaction. But don't worry, we're going to get to the changes in these chemical reactions very soon. So don't worry about that. For now, we are getting there. Okay. So bond breaking and bond formation. Okay, that's the next thing that we're going to speak about. In a chemical reaction, bonds break in the reaction to form new bonds in the product. Do you understand? I think I've already explained that more when I said that bonds will break. For example, you find HCl gives you H2O plus O2 plus HCl. So they just keep swapping and changing. I'm just making an example, but they always keep changing, as we've seen in most of the problems that we've done before. Let me just see if I can get an example from one in our homework. I just want you guys to see what it means when they talk about bonds formation, bonds breaking, and bonds forming. Yes, for example, here, if you look at this number 10, you can see that this is HCO plus O2 gives you 2CO2 plus H2O. What has happened in this side? In this side, you had bonds formed. So this chemical, this compound on its own has formed bonds. These have bonds that are formed onto your carbon, and these two also have bonded to each other. So what does that mean? It means that here, in order for this reaction to take place, these bonds here all have to break. And in this case, we use the enthalpy, which is the energy that is used to break these bonds. And when we break these bonds, we need them again. We need that energy again to form the bonds on our product side, because now they break, but when they break, they need to rebond again. And when they rebond again, we need that energy once again to form these bonds. So this is what they mean when they speak about breaking bonds and forming bonds. Okay, I hope you understand, but we'll come back to this problem again just before the end of the lesson, because it's the last problem on our previous chapter revision questions. Okay, so I hope you guys understand the endothermic and exothermic breaking bonds and forming bonds. So this is what always happens. The bonds break, but they have to form again on your product. Okay, so the bonds are what links the compound of the reactants together. For the reaction to take place, they have to be broken. For that to happen, certain energy is required. Okay, so what they say here is that this process of breaking the bonds, remember we said we use the enthalpy to break the bonds, and we use the enthalpy to form the bonds. But what is the process of breaking bonds? This process of breaking bonds is called the endothermic process. Okay, so an endothermic process is the process of breaking the bonds in a chemical of the chemical reactant. Okay, I hope you guys understand that. Okay, so now we also have bond energy, which is the energy required to break the bonds so that the reaction can take place. So they say here bond energies. So we've got the endothermic process, which is the one that we have on the other side, which is used to break bonds. But then we also have the bond energy that breaks the bond so that the reaction can take place. So these two they are closely related, these terms. Just make sure that you know them so that, for example, if you get into an exam and they ask you a multiple choice, that you don't get confused. So the endothermic is a process, bond energy is the energy. So they're both breaking bonds, but one is a process and one is about the energy. So don't forget that, okay? So bond energies are measured in units of kilojoules per mole, okay? Please, guys, I hope that you guys are following through. Um, so now let's quickly go back to our textbook. I think now I'm going to go to the Siavula because I'm still following through the same section. I just want to show you, but I feel like it's better explained on the Siavula one. Okay, so we've done the endothermic breaking and bond formation. So before we continue, I just want us to do this worked example. But in order for us to know this, how this worked example is done, there's steps that needs to be taken. So the first step that we're going to take, it says you write your chemical reaction. So which is our chemical reaction that is here? The O2 plus 2H will give you 2H2O. Balance it out, and that is your balance equation. Okay, use the given values for the average bond enthalpy to calculate the enthalpy change for breaking the bonds. Okay, so you check here on your chemical reaction. They say calculate the enthalpy change of breaking bonds. So breaking bonds is this part, is the reactant side. Always remember that this is the reactant side. We need to break the bonds in order to form them in our product. So they've gave us our enthalpy, which is this part here, bond enthalpy, and you need to calculate it. So you're going to add it together. So you're going to say O2 in this case, O2, it's one compound, right? So you make sure, guys, don't say because it's O2 here, then you're going to say 496 times 2. Remember, this is only one compound, okay? So we're going to say 496. We're going to take it from here, plus the H2O. So H2O, it's also one compound. So we times it by 2. 2 because we've got a number 2 here, which is the number of moles of this compound, the hydrogen gas. So we're going to say 2 times 436. I hope you guys understand what this means. So this is how we calculate our heat absorbed. Our heat absorbed is always what we have on our reactant side. Don't forget that, guys. And we always put it in kilojoules per mole, unless you say times mole to the power of -1, but it's better to say per mole so that you avoid having to write the -1. But it's physics. Anyone can do it the way they prefer, okay? So now we know the calculation for heat absorbed. It's going to be the addition of our reactants, okay? And then after that, we calculate the enthalpy change of forming bonds. Remember, on our reactants, we break bonds. On our product, we form bonds. Always remember the two. Break bonds, form bonds. Break bonds, form bonds. Okay? So here on the heat released, it's going to be 2, because we've got H2O here. It's going to be 2 times 2 of minus 463. Okay? Which is this one that is given here. And that is going to give, but this one is a minus. The ones of the heat release, our heat that is released is always a minus. Don't forget that, guys. It's always a minus. When you release heat, it is a minus. That's why if it's balanced, our change in heat will be 0. So it's unlikely. They always have to be different in order for us to calculate them. Okay. So then here we've got our H2O, the OH. We've calculated it here. And then now we determine the overall enthalpy change. And how we're going to do that? We're going to say change in heat is going to be heat absorbed to break bonds plus heat absorbed to make bonds. Okay, so it's plus break plus make. Break plus make will give you our change in heat. But our forming bond energy will always be a minus. So don't forget to always put a minus there. Okay. So change in heat is negative. So if your change in heat is negative, this would mean it's an exothermic reaction. Remember what we spoke about when we said I think we spoke about it here. Yes, when we spoke about it on these two, that if your triangle H is greater than zero, then it's endothermic. But if it's less than zero, which means if our change in H is a minus, then it is a exothermic reaction. So that's how they got it here. I hope you guys are still following through because we need to be able to do our homework after this, and we need to understand each and everything. So wherever you're getting stuck, just let me know and I'll go back quickly and explain. So now we're going to do endothermic and exothermic reactions in everyday life. But I prefer to do it on the Siyavula textbook because the Siyavula textbook, has packed them in order. You know which part is your endothermic ones and which part is your exothermic ones. So I chose specifically the Siyavula textbook for this part. Okay. So they say there are many examples of endothermic and exothermic reactions that occur around us all the time. The following are just a few. So that on our endothermic reaction, we've got two of them that we're going to speak about. We're going to speak about photosynthesis and the thermal decomposition of limestone. So photosynthesis is a chemical reaction that takes place in green plant. Yes, I know you guys know it because most physics students are also doing life science. So most of you should know what is photosynthesis. Excuse me to the accounting guys, but so it takes place in green plants, which uses energy from the sun. Okay, so already we're getting into endothermic because we're talking about energy that is taken from our surrounding. Um, to change carbon dioxide and water into food let the plants survive and which other organisms such as humans and other animals can eat so that they too can survive. So what happens? So it's going to be carbon dioxide plus H2O. So we've got our little plant here taking in our carbon dioxide and H2O plus the sun. This case, our energy is the sun because we need the sun for this reaction to take place. And this will give us this nutrients plus oxygen. Okay, so what does this mean? Because energy needs to be taken in this case, this has to be an endothermic reaction. So photosynthesis is endothermic reaction. Energy in the form of sunlight is absorbed during the reaction. Guys, all of this information is important and it's in theory that you guys need to always know. So if you don't understand something with regards to this, just let me know. Okay. And then the second part, we've got the thermal decomposition of limestone. Okay. In industry, the breakdown of limestone into quicklime and carbon dioxide is very important. Quicklime can be used to make steel from iron and also to neutralize soils that are too acidic. Okay. However, the limestone must be heated in a kiln oven at a temperature of 900 before the decomposition reaction takes place. So you see, there's a condition. For this reaction to happen, it has to be heated at very high temperature. And that very high temperature, what is that? That is energy, that is heat. Okay, so this is an endothermic reaction. So we get CaCO3, which gives you CaO plus CO2 gas. Okay, so that's why this is so anything, as long as you need to light up with a match, or you need sunshine, or you need to heat it in an oven or a stove, that is an endothermic reaction. Okay, I hope that you guys understand more or less what an endothermic reaction is. Okay, then now we're moving to number two, which is exothermic reactions. The number one exothermic reaction that is loved in physical science is a combustion reaction. The burning of fuel is an example of a combustion reaction, and we humans rely heavily on this process for our energy requirements. Okay, the following equation describes the combustion of hydrocarbon such as petrol. But if you guys remember properly, we've spoken about a combustion reaction earlier on in chapter 5. On close to the end of the chapter, we did some explosions. Those explosions are exothermic, and I did mention that it's an exothermic reaction because heat is released. Okay, so in this case, we have fuel and oxygen. You can only imagine what fuel and alcohol can do. Obviously, it's going to bring up heat, water, and carbon dioxide. This is more or less, oh, that's why we burn fuels such as paraffin, coal, propane, and butane for energy, because the chemical change that take place during this reaction release huge amount of energy. Okay, so for example, with a paraffin stove, you will have your paraffin, and then but you need a lighter to light your match, and what you get as a result is fire. So that fire there is the energy that gets released. So that energy released is more than the energy that was inputted into this equation. Okay, so I hope that makes much more sense to you guys. So hence we've got CO2 HO plus heat that is released. I hope that makes sense to you guys. So you should note that carbon dioxide is produced during this reaction, the chemical reaction that takes place when fuel burns both positive and negative consequences. Although the benefits from heat, power, and electricity, the carbon dioxide that is produced has a negative impact on the environment, which is something that we've spoken about and we're still going to speak about in the future. So don't worry about carbon dioxide, we'll get to it. Okay, so the second one is respiration. Respiration is also an exothermic reaction. So respiration is a chemical reaction that happens in our bodies to produce energy in our cells. Okay. This equation below describes what happens in this reaction. So we've got C6H12O2 plus 6O2 is going to give us 6CO2 plus H2 plus energy. Okay. So what does that mean? It means whenever you take for example your type of food that you eat, you're going to take it, your system is going to burn it down, but the resultant thing of that food, basically it gives you energy, gives you water, it gives you carbon dioxide to your cells, but it also gives energy to your cells, and you need energy to survive. So that's why we eat food. So this is what it means with the respiration. Okay, this reaction above, glucose, a type of carbohydrate in the food that we eat, reacts with oxygen from the air that we breathe to form carbon dioxide, which we breathe out. Carbon dioxide and water and energy. Okay. Let me just here. Why is it exothermic whilst it can also be endothermic? Okay, what I mentioned, remember what makes it exothermic or endothermic? It depends on the amount of heat that is used and the amount of heat that is released. Remember what I said before? I said that the amount of energy used to break bonds, for example, the amount of energy used to break the bonds this side is so much less than the amount of energy that is released. Okay, so you're going to use a small little matches to light the fire, but the energy that is released here, let me just go there. Yes, yeah, you might need, for example, if it's a primer stove, let me just make an example. You're going to use that small matches to light the fire, but the heat that is released is more than the heat that is used to break the bonds. Do you guys understand me now? If you understand, just send me a sharp finger. If this heat that is in here is more than the heat that is released, then it will be an endothermic. But if the heat that is given out in the product is more than the one that is used in the reactant, then this is an exothermic reaction. Okay, I'm glad that you get it. So let's continue. I think we just spoke about, oh, we've got 5 minutes left, but I'm glad that we've reached most of the stuff that we wanted to talk about. Okay. Okay. So now we're done with this one. So now I want us, before we go any further, I just want us to check on what homework we can do. So this one, this section, basically, we have we have we have summarized it using the Siavula textbook. So that's another textbook that you can get. But I hope that it made it easier, because here they're speaking about different things, but in small little parts. So that's why I chose to use that one, because it states these are the endothermic reactions, these are the exothermic reactions. So I hope that made it easier for you guys to understand. Okay. So now we get to our homework. Okay. I hope that you guys are going to continue doing your homework, because homework helps us understand our work better. I know that there's obviously no teacher that's going to spank you for not doing your homework, but if you do your homework, you're doing it for your own good. It's going to help you understand your information better. So, I don't know. Let's start with number one here. Okay, this one we can do it quickly. It says classify each of the following reactions as either endothermic or exothermic. Okay, so number 1.1, it says H2O plus heat will give you H2 plus O2. So isn't this obvious? This is heat that is taken in. So this is an endothermic reaction. Okay, because the heat is in our reactant part. So they're taking in heat, so this is an endothermic reaction. So the number two, they say magnesium plus chloride will give you MgCl plus heat. So this one, we are releasing heat. So heat is exiting. Remember, exo, exit. Endo, inside. Okay. So here, with the endothermic, exothermic, if heat is released, then this makes it an exothermic reaction. I hope that you guys will be able to remember by using exo, because if you can just memorize that exo means exit, you always know whatever you get, there's no heat that is exiting here, so it means it's endo because it's inside. So this is an endothermic, but in this side, exit heat, it means that it's an exothermic. I hope that that will help you guys in understanding more on which one to choose at every single time. Okay, so for homework, I think that we can do, let's do number 3 and number 5, because we've done number 1, so which means we're doing odd numbers. Let's do number 3 and number 5, and then you guys can do it for tomorrow, and then tomorrow, before we get done here, then we can start with our next problems. Okay, so we're going to do number 3 and number 5. Number 3, as you guys can see, number 5 is quite long, but it's okay, because that's how we learn, by understanding questions, and also explaining, answering questions. So that's what it's all about. So we're not going to do, obviously, the experiments, because we do not have equipment and we do not have laboratories. But you guys can read through these experiments and just know them, just for self knowledge. Okay, and tomorrow we're going to be starting with our endothermic and exothermic reaction. Okay, oh, we've got 1 minute left, and I forgot about our homework that we still haven't done, but it's going to require a lot. Okay, um let me see. Go back to number 5. I want to take a screenshot. Okay. Uh, okay, guys. Yes, so this is number 5. So this is 5.2 and 5.3 and 5.4. I hope that you've taken the screenshot, and And then on this part, I hope you guys have taken screenshots of this as well. Guys, um, thank you so much. This was a beautiful lesson, and I hope that you understand the first part of changes during chemical reactions that we've done today. And tomorrow we are continuing. We're going to do one unit each and every day until we get to the end of the chapter to make sure that everybody understands all the work that we're doing. So, guys, thank you so much. Reminding you again, we're using the Oxford Successful Textbook, and you can get it on Snaplified if you do not have it. Nonetheless, I am Nonkululeko Madondo. Thank you for joining me for Physical Sciences Grade 11. Let's meet again tomorrow at 12 o'clock, 12 to 1. We have